This is fine.
I'm gonna skip the start of 3.2 and I'm gonna go straight to this thing called Brahmagupta's formula.
Ah yes, Brahmagupta.
So this is theorem.
Okay, let's find the book
3.22.
first.
Theorem
Your
3.22.
emails.
Yeah, I did
So
at home, but
Brahma-
I had too many unread emails. It just didn't load all of
Search
this.
a microson or geometry.
Yeah, that's what I searched on Microsoft. I'm just going through like.
Oh, this is formula, not
Does he
theorem
send you
formula.
that many emails? It seems like once a week. So the fact you have so many.
Did you get my last email? Some of those emails are not unnecessary, I guess. Alright. Brahmagupta's formula, okay?
It's, I thought it starts
Is it
with the
Indian?
Yeah, that's funny.
Yes.
It says Brahmagupta
Isn't he
in the
Indian?
7th century AD was a Hindu mathematician.
Yeah, he's
The
Indian.
last name's longer.
Yeah.
Like
So I don't know why they distinguish Hindu from Indian because
No, before all Indians were Hindu.
Yeah,
Yeah.
but we're all Hindu Indians.
Yeah.
well, I guess
Oh, no, they could be
India,
Nepalese.
India split up into like Pakistan and stuff.
And
What do you
Nepal.
mean? Like, what do you call it?
And I'm pretty sure some of them are
Korean people
Muslims.
can be Hindu.
No, not before.
They couldn't.
They weren't Hindu before.
Alright, this is not the
I don't
greatest.
think
Like
Koreans
Japan,
even
you
like
can-
interacted with Indian people.
Okay, so you
back
have a
then.
circle, right?
It's too far back.
Okay.
Like,
Actually,
even
this
the
is
British
something.
didn't
This
do
is
that.
something ideally I would hope you can do as an exercise. Okay.
To prove it.
Yeah.
Oh.
So it's basically you have a cyclic quad. Yeah.
I found it.
Okay.
Good job, Kavan.
Say you have. So maybe we call this A, this B, this C, and this D. Yeah. Okay. And then we can define like the semi-perimeter.
Oh,
3.2,
Half
page
A plus
56.
B plus C plus D. Yeah. That's the semi-perimeter. It just makes that formula look easier. So it's the perimeter
Just the
times divided by
I
perimeter.
2.
shouldn't star that email.
It's just
Perimeter
half of the
divided-
perimeter.
oh,
Yeah.
I'm gonna put a star in
Alright.
that email.
So the formula, so to prevent you from being further behind, you might want to pay attention. Okay, so the formula is for the area of this squared. Okay, so the area of the quadrilateral squared,
Yeah.
is equal to S minus A. Have you done this?
Heroin's
I read
formula.
Isn't that Heron's?
No, heroin's
Wait,
That's
that's-
what we're trying.
No,
This is-
Heroin's formula.
Oh come on!
That's what I thought he said.
Like that stuff is fine. It's like when there's nothing else to think about, that's funny. But when there's something interesting to think about, focus. Okay, so that's the formula. Okay.
Midpoint.
So have you heard of Heron's formula?
Yeah,
That's
that's
how-
what we just said.
Yeah. So do you know what that is?
Yeah. What do you mean? It's like the same thing except without the D.
Yeah. So the Heron's formula.
It's a triangle, not a,
Yeah, so-
not a square. It's the same thing.
No, I don't think the formula.
Maybe I can talk about Heron's formula
Yeah.
a bit later. But if you have like
Yeah,
A,
it's the same
B,
thing as
C,
Yeah,
right?
because it's a triangle.
Yeah.
It doesn't have a fourth side.
The area of
It doesn't have
the
a fourth
triangle
side.
squared.
I
Yeah.
said it was without the
Is
D.
equal to
That's what I
S.
said as well.
S minus A.
Why would you repeat what I said?
S
I
minus
said
C.
it's a
Yeah.
triangle.
Okay, good job.
Okay. So in some sense, it's a special case of that formula, right? If you kind of make D go to 0.
Yeah.
Okay. So if you can prove this, then you have a good argument.
prove it.
Make
to
B,
prove
C, and
this.
D coding in.
Yeah, but making D 0, we'll have to come back to that, okay? Because I think the better you are at maths, the more believable that when people say make D 0. But if you guys are just beginning and you say make D 0, I don't think I'll believe you, okay? So, yeah, but can you kind of basically see if you made D 0, right?
It just works.
That would give you the right hand side, yeah?
Yes.
And it would also give you a triangle, yeah?
Yeah.
I think I remember how to prove Heron's formula.
Yeah.
I know, I've seen like the proof for Heron's formula before. Like a lot of times.
Isn't it with lots of tree?
So, yeah, like, let's go through some tricks. So I guess
Why did you make
I would hope, I want to actually know how much trig you know,
I fucking
okay?
love trig.
But this should be easy if you know trig.
I'm
Okay.
quite a
I was trying to match the question to 3.1 with Chris.
Oh. Okay, so can we kind of just do this together? So let's call this n, yeah? Okay, so you remember what the formula is? I can erase that.
Let me try proving this.
I got to Napoleon's triangles, but okay, finally.
What are you looking at?
Oh, come on, can
He's
you?
looking for the book. Why? Why do you even need the book?
You already found the book.
Yeah, no.
Looking
in
for
the
the
book part.
Yeah.
Yeah.
Oh, by the way, so the reason I'm not going to teach you too much trig is because it's actually part of school, okay? So, like, you can actually learn trig at school. So,
All stops essential.
The reason why
I can clear up some, like, technicalities about trig if you have questions.
Sine
But
and
essentially what trig is it executes on congruences, okay? So basically, like, you know, like SAS determines the triangle, yeah? So that means from SA and S, you should also be able to figure out the other S. You should be able to figure out the other angles. So trig gives you basically all the formulas to do that, yeah? Same with area, everything, yeah? So Heron's formula is just SSS to area, right?
Oh.
Yeah?
Yeah.
So
Oh,
here, you know, one natural way to do it is if we know triangles, you break it up into triangles, right?
yeah.
So then, like, you have an area formula for SAS, so you might have to write
Just
an
cut the
angle. in there.
diagonals.
Maybe we call it an angle alpha and beta, yeah?
Cut the diagonal. Oh,
you
just
can
like
call
that.
that, you can call that 180 minus alpha.
Okay,
Yeah,
so can
just
you
call
see?
it-
So you can see that the area is like half AB sine alpha, yeah, plus
Half A.
half
B
CD
sine.
sine beta, yeah.
No, but you can also write a sine beta as cos alpha.
Huh?
Because isn't that 180 minus alpha?
Yeah, 180.
So you can write that as.
Yeah, exactly. So beta is actually 180 minus alpha, yeah, because it's cyclic.
It's not close, right? Because it would have to be 90 minus.
Oh,
Yeah, it will still be
And then it would be just alpha here, yeah.
Yeah, it would just be.
So then the area is actually
Yeah, because you flip like that when it's
half.
there's no point.
AB plus CD sine alpha, yeah?
Yes.
Because sine beta is equal to sine 180 minus alpha is equal to sine alpha. Okay? So sine 180 minus alpha equals sine
I'm
alpha.
dying.
Okay? So then there's a common factor of sine alpha half, and then it's AB plus CD, yeah? Okay, so that's the area, okay? Alright. So you have like the sine alpha there, okay? So you want to get rid of the alpha basically, yeah? How can you get rid of the alpha? Well, you have like, how do you turn an angle into sine? That's like cosine rule, right? So for example, you have n squared equals a squared plus b squared minus
I'm dying.
2ab cos alpha, yeah?
How'd you get the first
Hey,
thing?
come on, if you die in camp.
That's like the area of the triangle.
Yeah.
Come on.
So the area of a triangle is this formula, yeah? Actually, you can prove it pretty easily. Just draw 9 degrees. Draw a perpendicular and then do like normal. But just assume it for this proof, yeah? Okay, and then n squared is like, if you ever do something for one thing, to eliminate the choices, just do it for all the other things that you could have done for, yeah?
Oh wait, then
C
you
squared.
solve it.
2CD cos beta, yeah?
Wow.
Okay, but then cos beta is just cos 180 minus alpha,
Which is alpha,
which is
isn't it?
is equal to minus cos alpha.
Oh,
Negative.
So then this becomes plus 2
Oh, yeah,
CD.
yeah, because you
Cos
cos
alpha, yeah.
minus x is equal to cos x.
Okay, so can you see now, like you can eliminate the n squared, right? Yeah.
No, couldn't you just make cos a the subject and then you get like this?
Yeah, there was already a formula for cos a, yeah.
Yeah, and then
Yeah.
you can just derive sine a from cos a.
Yeah.
Plus-
But it's all kind of the same. So you can equate the n squared to get rid of that. You have cos alpha.
2AB.
Yeah.
Plus 2CD.
Yeah.
Did you put 2 on that?
Plus 2ct equals a squared plus b squared minus c squared minus d squared, right?
Yes.
Okay. So just set these two equal and then put these on the same side and then put the others on the other side. Okay. So then you get the 2 can come out now as well, yeah? Common factor of 2. Put it here. Oh. Okay, so 2 cos alpha times this is equal to that. And notice that's basically the same here, yeah? So that's half something sine alpha, yeah? Yeah, so maybe, so something to get it, so 4 times the area, right? Is equal to 2 AB plus CD sine alpha, yeah?
Yes.
Okay, times this is the area. I times it by 4, I get that, yeah? Okay, so the reason I did that is because now this looks the same, yeah?
Yeah.
Okay, and because we know that sine and cosine are like x and y on the unit circle, x squared plus y squared equals 1, right? Sine squared plus cos squared equals 1. Okay, so from that, you can just add these 2 squared together, okay? So 4a squared plus this thing here, right?
Oh no.
A squared plus b squared minus c squared minus d squared all squared, yeah?
Yeah.
That gives you 2 squared ab plus c squared,
Yeah, that's
And
just
then
it.
you can just
and then it's sine squared plus cos squared,
It's
yeah?
just 1.
Yeah.
Okay.
Does that?
And then you
just
move,
cancel
and then you
everything?
move that to that side, and then you factorize it.
Yeah, so I'm gonna erase this and go down here, yeah.
It's just algebra now.
Yeah, it should be pretty easy now. So if we're here, then 4a squared, so that's 1, yeah? That's the point of that is this is 1. But there's no more alphas, okay? So it is just 4a squared equals a squared plus b squared minus c squared minus d squared squared. It's equal to minus that plus 2 squared ab plus cd squared, yeah? So now this is a difference of 2 squares. Is that obvious? So difference of 2 squares.
What's that?
What? Unlucky, imagine that. Wait, are you reserved?
Yeah.
Well, who's it for debating?
Well, who's in the
debating? It's like Darshni.
Dashnik, Ikra, Harsh, and Jennifer. That's the same as last year.
Yeah.
Can you like not check your email? Like if you're really far ahead, maybe.
Yeah, I just don't understand. That's one thing.
Minus a squared minus
I'm
b
still trying to
squared
figure out that first thing.
plus c squared.
What?
plus
It's just.
d-
One first.
It's just the
It's a triangle area.
I see the triangle area.
Wait, 1/2 AB sine alpha.
That's just.
Wait, you want the proof of that?
That's what I'm trying to do.
Wait, you're trying to prove half AB sine
Yeah.
alpha.
That's literally just the area.
It's just the area of a triangle. No,
Right.
think about it. Because you have a random triangle, right? And then you can just draw the altitude, right?
Mm,
And that's 90 degrees.
yeah.
So do you want me to prove it on the board? I can prove it.
Okay.
Alright, so actually I don't know if you can you need an angle sum for that? I mean,
Wait, sine alpha plus beta
yeah.
is equal to sine alpha cos beta plus cos
Maybe
alpha.
it's not as obvious, just straight up.
Let me try proving it.
I'm trying to do this.
Yeah, but like there is a certain skill in actually just assuming it and using it, yeah? Because there will be situations where you can't
Yeah,
prove
just
something.
say like.
Yeah?
Oh yes, I remember this.
Like, I mean, you can, but there's just not enough time to prove it, yeah? Okay. So this is the difference to squares, yeah?
Mm-hmm.
But see, now you're kind of not with us.
But is it 4a squared or 4 squared a squared?
4 squared a squared.
Well, on the left side. On the left side. Below. Because like before you wrote 4 squared a squared. And then
Oh, yeah.
Oh.
So then this is just the same with a plus now, right?
Yes.
So 2ab plus cd plus a squared plus b squared minus c squared minus d squared. Okay.
Okay, come on with it.
Wait, what did you do? Oh, you just add the two because.
Yeah, I mean, trig is kind of a funny topic. It's not really part of AIMO, but it really helps if you know it.
Yeah. I should get better at code bashing because, like, half of the questions in AIMO and AMO you can just code bash.
I mean, there was a question this year that people did code bash.
Bro, like my friend, apparently he did all the geometry, like just code bashing it somehow. And like vector bash and weird names.
I mean, eventually you're gonna have to learn how to do geometry too. I mean, it's not.
Vector bashing sucks.
Okay, so is it obvious how to proceed from here? So this is like a lesson in algebra almost.
Yeah.
That looks so annoying. Oh, actually. Do you have to expand? Oh no, it's just square.
A squared minus b
Yeah,
squared.
it's
You
just-
change it
just
into
C plus D.
a
So these are
minus
perfect
b
squares.
plus
These
b.
are all perfect squares,
Yeah.
right?
Yeah.
So a squared b squared. That's
That's negative.
And
A
then
minus
c
B.
squared plus 2cd plus
so
d squared.
2ab and that is just a minus. It's just a
Yeah.
plus. It's a
A
minus
minus
b
b.
Negative
whole
A
squared.
minus B
squared
Negative.
negative. Yeah.
Yeah.
And then 2cd and that is c
Is
plus d
positive.
squared.
C plus d whole squared.
Okay. So that's now a difference of squares. Yeah.
And then the other one's the other way around.
So the other one's the same, right?
But it's other way.
So a plus b squared.
Yeah. And then it's
Yeah.
a
Negative.
minus and then
C
c plus
minus
d.
C
C
minus.
minus d squared.
Okay.
C
So
plus
difference of
D.
two squares.
C plus D plus
Difference
A
to-
minus B.
Wait, what? Yeah.
Okay, and then c plus d
Minus B
Minus-
plus A.
minus a plus b. Yeah.
Oh yes.
And then you
And
can
then it's a plus b minus c plus d.
Wait.
A plus b
Oh,
plus c
C
minus
plus-
c. Yeah.
Does that?
Yeah.
Does that prove?
can you
So
Does that prove it? Does it? No, but you
No.
have three. Like it's weird.
so 3. Yeah. So 3 is like, but the thing is, it s is like. So if you had all 4, right?
So that's like S minus 2B, right? And that one's S minus 2A, that's S minus 2C, that's S minus 2D.
Yeah, no, it's
Wait,
two
no,
S.
it's not. Oh yeah, it's 2S.
So this is.
Wait.
Oh wait, no, that makes perfect sense because no, it's basically 2s minus a times 2s minus b times 2s minus c times 2s minus d, and if you
Yeah,
just
I need
multiply
to
the
divide by
260,
all of
and then just cross the
No,
60.
no, it's 2s minus 2b. Yeah.
Yeah, but
Yeah, but
it's
then you
all
can
out.
take the 2 out.
Yeah.
And so then you swap it.
So can you see like? So can you see this is 2s minus 2b?
Come on.
Yeah. Because 2s is the perimeter, right?
Yeah.
2s is the perimeter. It's a plus b plus c plus d. So 2 of them is all of them. If you minus 2b from that, you get the 3 of them minus b,
Oh,
right?
go over there.
it
Yeah?
bounces off my hand. I turned it.
So it makes sense.
Yes.
So if you take a plus b plus a and you minus 2b, what do you get? You get a plus c plus d minus b, yeah? We agreed on this?
Yes.
Yeah.
Okay, so it's the same for all of them, yeah? So it's
When it comes
2s
to
minus
algebra, it makes sense. When it's in geometry, no.
2s minus 2c, and then 2s
Next one.
minus 2d, yeah? Yeah? Okay, and then so there's how many 2s? 1, 2, 3, 4, yeah?
Yes.
And then,
1, 2, 3, 4. Yeah, it's also. They're both 16.
yeah, so there's 16 and then there's 16, right? So then a squared is what we want it to be.
Yes.
Yeah? Yeah. So if you wanted to set d equals 0, okay, I think like the first most direct way of setting d equals 0 is to actually set d equals 0 and see if the argument works, right? But does the argument work? I mean, once you set d equals 0, like that angle, is that angle? I mean, it's nice that all 3 points lie on a circle, so that's nice. Yeah, you need that.
Like you can just move the point D like infinitely close.
Yeah, so that's what I want to say. Okay, so but this doesn't actually prove it now. Okay, that's the difference. Yeah, it's more convincing even. You have to actually kind of understand.
That literally looks like.
So what happens? Like if you move D really close, if you make it really close to 0, right? Then you can believe that the area is as close. The area is really close to the area of a triangle. Yeah. And the point is, this is what you actually need to prove, but I think you can probably believe it pretty easily. It's like you can get as close to the area of the triangle as you want by making D small enough. Yeah? That's what you need. And then you need to know that this right-hand side formula also behaves that way, okay? So if you make D as close as you want to 0, then the formula is as close as you want to the formula with just S here instead of S minus D. Yeah? And you can kind of believe that intuitively, even though you can't probably prove it right now. Like, if you type in 4 numbers and you calculate the time together, if this number's like 3.1, you know, or if it's 3.10001, you'll get similar answers. Yeah? Okay? So I think intuitively it feels safer to actually let D get really close to 0 to get Heron's formula. Okay? Okay, cool. Yeah, so this is like Brahmagupta's formula. And then the last theorem in that section is also something from Brahmagupta.
Bruh.
Okay, and then that's...
More like a Brahm.
Alright.
Okay.
Wait, is this from 7 BC?
Huh?
Is this the
Yeah,
7
no,
BC?
it's 700 BC.
How do you
7,
still
8.
have what? Wait, wasn't it from like 1700?
Well,
What
no,
is
no.
the name
7 AD. 700 AD.
Bro.
Yeah, 700 AD, not BC. sorry.
700th century AD.
Yeah, he said 7th century. 700th century.
700 Wait, and he had a name called Brahmagupta.
Yeah,
Why not?
why not? Are you saying Indians can't be smart in 7th century?
In fact, you could deduce that from that. just told you you have a racist mind.
Hey, Chuck.
Such
Chuck
a-
the thing.
Bro.
No, not that.
Can I have the
Not that.
crispy cream hat?
I have that Krispy Kreme hat.
It is. It looks